Hello, girls. Today we're going to finish up Chapter 5 with 2.5, Section 2.5, Logarithmic Functions. And again, this is just kind of an overview and review for you guys from last year. So if we look at logarithmic functions, remember, logarithmic functions is just another way to express exponential functions, right? And you can go back and forth between the two using these little formulas. So log base a of x equals y is the same as a to the y equals x. And remember, a natural log, the ln, is just another way to express an e function that we talked about last time. And you just don't have to write the e as your base. So you've got natural log of x equals y is the same thing as e to the y equals x. So as we look down at some examples about going back and forth, we can, so the purpose of this next activity is to take the exponential form and write it in the log form. And if you're given the log form, write it in the exponential form. So for example, this first one, 3 squared equals 9, or 3 to the second equals 9. So if we wanted to write it as a log form using these, using this little formula, we would say log base 3 of 9 equals 2. So again, keep in mind that the exponent of an exponential equation becomes the answer to a log equation. Okay, next example, 10 to the 5th equals 100,000. So we would write log base 10 of 100,000. Log base 10 of 100,000 equals 5. Now on a log function, the default is 10. So if there's no base written, it defaults to 10. So this could also be written as just log of 100,000 equals 5. So either way. Okay, now the next example, we were given a log form and we want to write the exponential form. So we've got log base 4 of 1/64 equals -3. So to rewrite it as an exponent, we would say 4 to the -3 equals 1/64. Okay. Next example, log base 1/5. Sorry about that, I've got something going on here. Okay, next example, log base 1/5 of 25 equals -2. So if we were to write that as a exponential equation, we would say 1/5 to the -2 equals 25. Okay, so again, we're just going back and forth using these equations up at the top. So next example, we want to write the log equivalent of 15 to the x equals 287. So we would say, again, log base 15 of 287 equals x. Next example, log base x of 13 equals 7. Again, to write that as a exponent equation would be x to the 7 equals 13. Okay, moving right along. Now, e to the 5th equals x. Again, that's telling us we're going to use a natural log, because remember, log base e, right, it's the same thing as just ln. So it's kind of a shortcut. So you don't want to use log base e, you want to use ln instead. So writing e to the 5th equals x as a log would be just natural log of x equals 5, because that takes care of natural log base e of x equals 5. Similarly, e to the 0 equals 1 would again be natural log, so that gives us log base e of 1 equals 0. Okay, and last example, to go from natural log to exponents. Again, when we have a natural log, that means we're dealing with the base of e, so this would be e to the 7th equals x. Okay, so again, main reason we're looking at this, so again, the main reason we're looking at these different conversions is to be able to solve equations easier. So the main takeaway you want to take from this lesson is these two statements right here. So when the variable is an exponent, you can convert it to a log form and it becomes your answer. When a variable is the argument of a log, you can convert it to an exponent form and again goes to the other side of the equal sign. So let's look at some of those problems. Okay, so first let's solve these logs without a calculator. And these are just, we're going to solve them by changing them to exponents and evaluating them. So, for example, if we say log base 3 of 81, okay, off the top of our heads we may not know what that is. We could use a calculator, but it's easier if you wrote it as 3 to what power equals 81. And again, the powers of 3 we're pretty familiar with, so 3 times 3 is 9, times 3 is 27, times 3 again is 81. So 3 to the 4th equals 81. So the answer to this is 4. Okay? Let's go down below here. So log base 2 of 1/8 equals what? So again, we want to think of this as 2 to what power equals 1/8. And again, to make 2 a fraction, you're going to have a negative exponent, right? And then if you take 2 to the 3rd power, it equals 8. So 2 to the 1/3 power, 2 to the negative 3 power will give you 8. So the answer to this equation right here is negative 30. Okay? If we look over here, natural log of e to the 5th. So again, think of natural log meaning a base e. So this is saying e to what power would equal e to the 5th. Okay? And actually, to get this to equal that, the answer is 5. Okay? Log base 9 of 3 equals what? Is again asking the question 9 to what power equals 3. And this was a little bit tricky because the relationship between 9 and 3 is the fact that 9 is the square of 3, right? Or 3 is the square root of 9. So to express the square root as an exponent, we would use a fraction, which would be 1/2. So the answer to this equation is 1/2. Okay? Okay. Next, if we need to use a calculator, okay, again, we can use a calculator on any of these, basically using what you may have learned as a change of base formula. But the shortcut that I use to solve these with a calculator is log tall divided by log small. So for those of you who may not be familiar with that, when we want to solve this equation, the tall number is just the one written taller. So take it exactly how it sounds. So 37 would be the tall number, and 2 would be the smaller number. And again, I'm referring to the height of the numbers, which is a little bit strange. But if we want to find a numeric value for this, we would type it in on our calculator as log 37 divided by log 2. And if you enter that in your calculator exactly how I have it written, you may need parentheses around these, you will get 5.21. Okay? Try the next one. ln of 52. Again, this one, because it doesn't have a base, or ln always has a base of e, this one you can type in exactly how it looks, just using your ln key of your calculator. So ln of 52 equals 3.95. Okay? If we look at the next one, so log base 4 of 125, again, we want to type it in log of the tall number divided by log of the small. And if we type that in exactly how it looks, we get 3.48. Okay. Last one, log of 34. And again, like I mentioned earlier, if there's no base written on the log equation, it is a base 10. So you could do log tall over log small, or you can just, because again it's using the base 10, you can just use the log button on your calculator and just type it in as log of 34 and hit enter, and the answer is 1.53. Okay, so again, that's how to change a log expression into a value and solving some equations. So now we are going to solve some interest rate equations using logs. So last class we were only able to really solve for A and P using exponents the way it's written. Today we're going to use the same formula, but we're going to solve for T and R using logs. So for example, with an annual inflation rate averaging 5% per year, compounding annually, how long will it take prices to double? So this is kind of a common problem. When you see prices to double, again, it doesn't matter exactly what numbers you put in there, but you just want A to end up being twice as large as P. So therefore, we can use the easiest numbers we could think of. So we could let P be 1 and A be 2. So if we fill out our formula using a 2 for A and a 1 for P, because again, it just matters that A is double P, we get 1 plus our rate, which is 0.05, divided by our N, which is compounding annually, so N equals 1, taken to the N, which again is 1. Oh, sorry about that. 1 times our T, which is what we're trying to find. So T is our variable that we're trying to solve for. So to solve this, we simplify this, so we get 2 equals 1 plus 0.05 divided by 1 will give us just 1.05 to the T. So now, again, we have an exponent, an exponential function, and we're trying to solve for the variable. So if we rewrite it as a log function, the variable goes on the other side of the equal sign. So we can rewrite this as log base 1.05 of 2 equals T. So now everything on the left side is numeric, so we can plug it into our calculator. Sorry about that. So we would say log of tall divided by log of small, and we plug that in, and we get 14.21. So again, the answer is how many years it would take to double, and we're saying it would take 14.2 years. Okay. Next example. I want to invest $500 in a mutual fund. What interest rate do I need in order for the money to grow to $1,400 in 12 years if the interest is compounded continuously? So again, remember, when we see that compounded continuously, this is the formula we want to use. So if we plug in what we know, we want to invest $500, so that's our principal amount. We want to know what interest rate we need, so we're going to be solving for R in order for the money to grow to $1,400 as our ending value in 12 years. So we've taken care of all the information we're given, solving for R. So again, first thing we want to do is get that variable by itself. So we can divide 1,400 divided by 500, and we get 2.8 equals e to the 12r. Now again, our variable's in our exponent, so we want to rewrite it using a log, and because it's a base e, it'll be a natural log, so we would say ln of 2.8 equals 12r. Now again, to get the r by itself, we're going to divide by 12. So now the answer will be ln of 2.8, and just ln of 2.8. Don't include that 12 yet. So ln of 2.8 divided by 12. And we get 0.086, we'll say. So if we change it to a decimal, to a percent, it's 8.6%. Okay? Okay, next example. Jasmine received a bonus of $25,000. She invested in an account earning 7.2% compounded quarterly. How long will it take for her investment to grow to $40,000? So again, she received $25,000, so that is her initial amount. She invested in an account earning 7.2%, so we changed that to a decimal rate. Compounded quarterly, so n equals 4. So we get n as our denominator and up as our exponent. How long will it take for her investment? So we're trying to solve for t again to grow to $40,000. Okay? So again, here's our variable that we want to solve for, so we need to convert it to a log. So first we have to get that by itself. So we're going to divide 40,000 divided by 25,000. And we get 1.6 equals 1 plus 0.072 over 4 to the 4t. Now we want to simplify our 1 plus 0.072 divided by 4. So if we put that in our calculator, we get 1.6 equals 1.018 4t. So now we can rewrite it as a log. Again, we're going to say log base 1.018 of 1.6 equals 4t. And if we convert this to a value first, we're going to say log tall divided by log small. So we plug that into our calculator. And we get 26.35. I'll say actually 346 equals 4t. So to solve for t, we divide by 4. And we get t equals 6.59. So how long would it take for her investment to grow from 25,000 to 40,000 at 7.2% interest compounded quarterly? 6.59 years. So there were quick examples of all of the different types of log equations that we'll need to solve these interest problems. And your homework is on the next slide, which is from your book. So these you'll be needing to convert to log to solve, log or ln. So I'd like you to spend the rest of the class time taking a look at those and also some ACT practice if you're interested. Thanks. Bye.